Hi everyone, my name is Peter. Welcome to this YouTube tutorial. In this section, we are going to be discussing the pharmacology of anti-seizure drugs. And today's drug of choice is Tiagabalin or the brand name of Gabitril. So in today's objectives, we shall look at the mechanism of action of this drug, the pharmacokinetics, that is the absorption, distribution, metabolism, and then elimination. And then lastly, we shall look at the side effects of this drug. So therefore, to begin with the mechanism of action, so we've seen so many anti-seizure drugs with different modes of mechanism of action. Tiagabalin, what it does that it blocks the what we call the GAT1, which is the transporter GABA transporter 1. So what it does, it blocks this reuptake, or it blocks the reuptake of GABA through this receptor, or this transporter, the call it the GAT1. So therefore, when GABA is blocked, so we are going to see more of the GABA effect on the synapse. So that is when GABA binds on its receptor, it causes what we call excessive chloride ion influx. Excessive chloride ion influx. You know, when too much chloride ions enter the neural cell, it's going to cause depolarize. It's going to make it hyperpolarize. It's going to cause hyperpolarization. That is, the neural cell will not be easily stimulated. Hence, no more repetitive firing of neurons will be able to be transported or moved further to different glial cells. So what happens is that this gut transporters are found both on the glial cells and also on the neural cells, the neurons. So therefore, this drug Tiagabalin blocks on both types of cells. So therefore, we see more effect when this drug works on both the glial and the neural cells. So basically, that is the mechanism of action of this drug. Now, actually, this drug is like an amine. If to draw the structure over here, so this is the structure of Tiagabalin. So you see that this molecule is polarized, so it has the ability to cross the blood-brain barrier, the BBB. So it can cross the blood-brain barrier and and have its mechanism of action in the brain. So therefore, it's able to cross this blood-brain barrier. So therefore, to go to the pharmacokinetics of this drug, so the absorption, this drug is orally absorbed and it has a 90 to 95% bioavailability, and also to go to its distribution, it is highly protein bound. So whenever a drug is protein bound, so therefore it's going to take a long time for it to be like metabolized in the body, since it clings to the plasma proteins and is transported in that way. So it takes long for this drug to be eliminated. The metabolism, so this drug is metabolized by the cytochrome 3,450 enzymes and the isoform of 3A4. So we've seen so many drugs that are metabolized by these isoforms. So therefore, we shall see most of the anti-seizure drugs that I've been discussing are being metabolized by this type of isoenzyme. So therefore, Tiagabalin, given together with other anti-seizure drugs, its concentration in blood may be lowered due to the effect of the cytochrome 450 enzyme inducers such as carbamazepine, phenytoin, phenobarbital, and the valproate. So therefore, it's very cautious for prescribers to know that this drug its concentration can easily be lowered down when given together with other anti-seizure drugs. So consideration should be made. Its elimination, this drug is eliminated through the urine, and without the other anti-seizure drugs, enzyme inducers, it can be eliminated unchanged to a percentage of 30 to 4 to 55%. Not quite sure about this range, but with its elimination is generally eliminated. And to go to the side effects of this drug, one of the side effects seen with this drug is somnolence, which is excessive sleepiness. It causes dizziness. Since it causes the blood-brain barrier, we shall see more of the drowsiness. Dizziness, drowsiness, and also there's a problem in speech, slurred speech, and also some other known side effects like nausea and vomiting that are like signs of maybe toxicity seen with most of the drugs, but basically these are most of the seen side effects with this drug. So therefore, another thing to note about this drug is that it is, like I said, is affected by other anti-seizure drugs, but it does not affect them. So therefore, it is not a cytochrome P450 enzyme inducer, whereas the other anti-seizure drugs that I've been looking at have the ability to induce those enzymes. And some other last side effect can be depression. So this drug can also be given in also be used in a management of bipolar due to its ability to also work in the mesolimbic system of the brain. Since it's an amine, so it has the ability to affect other neurotransmitters that we have in the brain. So therefore, basically, that's all I had for today's section as far as Tiagabalin is concerned. Thank you very much for watching. See you next time as we discuss more drugs in pharmacology. Bye for now.